All right, today we're pulling back the curtain on one of the most important programming languages out there, Java. We're going to break down what it is, how it works, and why it's still such a big deal. Just think about it for a sec. That banking app you use, your favorite shopping website, even the massive systems that handle billions of transactions, what's that invisible engine making it all work? You guessed it. So often, the answer is Java. For decades, it's been the quiet workhorse of our digital world. So today, we're going to see how it goes from just a single line of code to powering these huge global services. So, to really get why Java is everywhere, we gotta ask, where did this thing even come from? Okay, so Java got its start way back in 1991, and the first version hit the scene in 96. But here's what's truly wild. All these years later, it's still one of the most popular languages on the planet. I mean, that kind of staying power it's almost unheard of in tech. A big reason for that is its core idea: write once, run anywhere. Basically, you can write your code on one computer and it'll run on almost any other. That makes it incredibly reliable, especially for big, serious systems. Now, if you want to understand Java, you have to get your head around its main philosophy, which is called object-oriented programming, or OOP. It's really just a way of modeling your code to look like the real world. It all kicks off with something called a class. The best way to think of a class is like a blueprint, right? It's not the actual thing, it's the plan for the thing. So a blueprint for a car would say, okay, it's got to have wheels, an engine, and it needs to be able to speed up and slow down. And then you have the object. The object is the actual car you build from that blueprint. It's the real deal. So from that one car blueprint, you can create a whole bunch of different car objects. A red Ferrari, a blue pickup truck, they all share that same basic structure, but each one is its own unique thing. This house analogy really nails it. The class is the architect's blueprint. It defines the layout, the rooms, the doors. The objects, well, those are the actual houses you build from that plan. They all have the same floor plan, but one might be painted green, another one has different furniture. You get the idea. You can't live in a blueprint, but you can live in the house. And that's the key takeaway. One class can stamp out tons of unique objects. Okay, so we've got our blueprints and our buildings. But how on earth do you organize thousands of these things into an app that actually works? Well, that's where Java's toolkit comes into play. Developers have this amazing set of tools to keep everything from becoming a total mess. You've got packages, which are basically just folders for keeping related classes together. Then there's inheritance, which is a super clever way to reuse code. Like a sports car class can just inherit all the basic stuff from a general car class. Interfaces are like contracts. They promise that a class can do certain things. And static members are special parts of a class you can use without even having to build a full object. These tools are absolutely essential for building clean, organized code that can grow. And this is where it gets really, really cool. We've seen the fundamental pieces, these classes and objects. But now let's zoom all the way out and see how they come together to build the apps that we use every single day. You know, most modern apps are really just a conversation between your device and some powerful computer in the cloud. And more often than not, Java is the one doing all the hard work on the server side. So here's how it works. Your phone, the client, sends out a request, something like, hey, show me my profile. That request shoots across the internet to a server, which is running a really smart Java application. That server then grabs your info from a database, figures out what to do with it, and sends it right back to your phone. This whole client-server dance is pretty much the backbone of the internet as we know it. But, of course, running a real-world app is never quite that simple. You've got to worry about security, you have to handle maybe millions of users at the same time, and you need the whole thing to feel lightning fast. So, ever wonder how an app keeps you logged in without you having to type your password over and over? Well, a lot of them use something called a JWT, or JSON Web Token. The first time you log in, the server gives your device a special temporary key. Then, for everything else you do, your device just flashes that key at the server. The server sees it, trusts it, and you're good to go. It's like a secure digital handshake that saves you a ton of hassle. And what about speed? I mean, if every single request had to wait in a single file line for an answer, big apps would just grind to a halt. So instead, they use something called event streaming with tools like Kafka. It's the difference between waiting in a long line at the post office versus just dropping a letter in a mailbox. Your app sends a task like, hey, process this order, and then just moves on.
That task gets handled in the background, which keeps everything feeling super fast and responsive for you.
And this mailbox idea opens the door to a really powerful design called microservices. Instead of one giant, clunky application, developers build a bunch of small, independent services. You might have one for user profiles, another one for payments, another for sending notifications, and they all talk to each other by sending these super fast messages. It makes the whole system way more flexible and easier to manage. So let's just tie this all together. It's pretty amazing, right? We started with this simple idea of a class being a blueprint, and we ended up with a global system of tiny services all talking to each other. And developers aren't starting from zero. They're using this incredible ecosystem of tools. Things like Spring Boot help them build the server applications really fast. Databases like MySQL give them a reliable place to store information. Kafka manages that whole high-speed mailbox system we talked about. And cloud platforms like AWS give them the power to run all of this on a global scale. So, from that very first class blueprint all the way to a worldwide network of microservices, we've seen how these fundamental ideas can scale up in incredible ways. It all just starts with those simple building blocks. So, I guess the only question left is, what are you going to build?